The open box problem is one of my all-time favorite calculus problems. Although unfortunately for you guys who aren't in calculus yet, we can't use calculus yet, so we're going to use our calculators to find the answer to this question. So here's how it works. We have a flat piece of cardboard, and what I'm going to do is I'm going to cut out a square from each of the corners. And so what's left will be sort of this plus shape, this cross shape, and what I'm going to do is fold up the remaining sides to make an open box. So if you need a visual for what's going on, that's what these diagrams down here are showing you. I'm cutting out those squares, I'm folding up the box, and I'm making this open box, a box without a top to it. What I want to do though is I want to figure out what should I actually cut out, like what size square should I cut out so I get the maximum volume. Like I could cut out a little tiny square and I'd have a long shallow box, or maybe I could cut out a really big square from the piece and I have a tall skinny box. But what should I cut out so I have the maximum volume is the question. So like I said, this is a calculus question, one of my all-time favorite ones, but for us right now who can't use calculus, don't know it, let's go ahead and just use some algebra and our calculators to help us do this. So what I need to do is write an equation that represents the volume of the box. Well, so to find the volume of a box, it's going to be length times width times height. Okay, let's consider this the length of the box. So it's not 20 inches because remember I'm cutting out an X and I'm cutting out an X from either side. So the actual length of the box once it's folded up down here in this final diagram is actually going to be 20, but then I've subtracted off not just one but two X's because I'm cutting X out from either side. Okay, you get that? Let's consider the width to be this piece right here. Again, not all the way across. 16 is the length of the cardboard, but I've cut out an X from that side and that side. So my width of this box is going to be 16, again, minus 2X, because I've cut X out from either side. And then I need to figure out what the height's going to be. Well, this is hard to explain from just the video because I usually am describing it with my hands and stuff in class. But your height of the box, if you imagine it folding up, that distance we cut out, X, is going to be kind of what gets like flipped up and folded as the height of the box. So the height of the box is just going to be X. Again, if you need me to kind of explain that in person, ask me in class and I can show you why that works. This equation then is going to represent the polynomial, or is going to represent the volume of that box. So there's our polynomial equation. What we'll need to do now, since again we don't have calculus to use, we're going to have to switch over and we're going to use our graphing calculator to find the maximum volume from here. So let's switch over to our graphing calculators and finish this problem out.